Hello and welcome to a presentation on MRI machines, what they are and how they work. Firstly, the physical and chemical basis of the techniques of MRI. MRI machines are very similar to NMR machines, specifically proton NMR. MRI machines find the concentration of hydrogen atoms in tissue, then use a signal given out by them to produce an amount of hydrogen atoms. There are many ways that an MRI machine can do this, with different types of scans. The two main types of scans that every other scan is built of and that we focus on here are T1 and T2 scans. The difference between the image that these scans give out can be seen here. There are also different magnets that can be used within an MRI machine. These are permanent, resistive and superconductive. The magnet used dictates the materials within the magnets and the temperature they must be cooled to. The most common type of magnet is superconductive. It must be cooled to 10 Kelvin with liquid helium and liquid nitrogen. Both T1 and T2 are often used together, along with other scan techniques. In this photo, you can see what the T1 and T2 scan looks like, and then what it looks like when they are overlaid together. First, the basics. This can be summed up as the pulses and the echoes. RF pulses are given out at different frequencies in a plane to excite hydrogen. This will cause the hydrogens to align to a specific direction. The return from this direction and back to equilibrium is what the machine measures. Echoes are the effect of changing the magnetic resonance with an RF pulse. The echo time is the time between the pulse being given off and the highest peak of energy being detected by the equilibrium being re-established. T1 scans detect the heat given off of hydrogen atoms using a spin lattice technique. This is where the hydrogen atoms are essentially excited by a specific RF frequency and then use the excess energy to give off heat. The heat released can then be measured by the MRI machine. This means that a T1 scan is essentially an enthalpy scan. This scan uses both short echo and short repetition times. The way this scan works means that it gives a much lower water signal than a fat signal. Contrast agents also give a good signal when being used with this technique. This photo with its key shows what a T1 scan of the brain looks like. T2 scans detect the entropy of the magnetized hydrogens by using a spin-spin relaxation technique. This is where the hydrogens are exposed to the magnetic field and they will align to a direction. Once the magnetic field is removed, they'll move back to their magnetic equilibrium. The time it takes for the equilibrium to be re-established is what is measured by the machine. So this method is essentially measuring the entropy of a system. This scan uses long echo and long retention times, unlike T1, and the way this scan works means that water gives a much higher signal than fat. Contrast agents don't work as well with this technique. This picture, along with its key, shows what a T2 scan looks like.
MRI data form a key part of modern medicine, but how do we collect it, and what can it tell us? As put by the NHS website, an MRI machine is a large tube that contains powerful magnets. Naturally though, there is a little more to it than just that. A traditional MRI machine is effectively a tube in which a patient will be moved, like the one you can see there. Typically, a patient will lie on the bed outside of the machine itself and then be conveyed in for a period of 15 to 90 minutes, to be analysed for a variety of possible illnesses. Using firstly a series of powerful magnets to orient the protons and the hydrogen and water molecules in the same direction, radio waves then send the protons out of alignment. It is their realignment with the magnetic field that allows for signals to be produced, which are conveyed to the radiographer, who is in a separate room to where the scan is taking place, to avoid the magnetic field interfering with the computer and hence ruining a potential result. Often, for such pictures, if you will, to be taken and transferred with clarity, a dye is injected into the arm of the patient. This cannot always be performed though, depending on the patient's health conditions besides. There are a number of types of MRI machine, including an open and standing version, but all follow the same concept. As is quite clear in the image here, and from the description, a typical MRI machine is large enough to fit a person inside and then some, and hence a whole large room to itself is required, already something hospitals often cannot give it before even considering cost, which is often astronomical. At best, an already used machine can go for in the region of £150,000 to £300,000, but many new machines will cost upwards of £1 million. As aforementioned, an MRI machine takes images as the patient is in the machine and sends these to a computer in a separate room to be analysed by a radiographer. MRI machines are probably best known for their ability to make brain scans, as can be seen in this top left image. They are, along with CT scans, the most modern and efficient way to produce a good quality scan of the brain. However, almost any part of the body can be analysed with one of these machines. One of their major uses is in the detection of cancer cells. This can be done because as the protons realign following the burst of radio waves, the data will effectively pick up on any anomalies in their positions, with a cancerous cluster naturally being a major anomaly. A major area of research in MRI now is in the area of prostate cancer. This is represented by the bottom right image, and in fact in 2019 the guidance for England was changed such that all men referred to hospitals with suspected prostate cancer ought to be immediately referred for prostate MRI screening. As I said at the start of the slide, analysis of MRI data is performed by a radiographer, a person who is able to, upon analysis, make judgments regarding whether some anomaly and hence issue exists, and henceforth medical treatments available to the person undergoing analysis.
Now I'm going to talk about the advantages as well as the limitations of this analytical technique. The advantages of MRI technique. The main advantage of this technique is that it doesn't involve or emit any ionizing radiation, which is found, for example, in X-ray imaging, which means that people are not exposed to the effects of radiation. The next big advantage of these scanners is that they can scan any part of the body from brain to spinal cord, as well as muscles and in any direction. It's also very detailed. It has a high quality and high resolution. Also, in comparison to CT scans, which mainly focus on the bones, MRI scan gives a much better differentiation between soft tissues such as muscle or fat, which means it's more useful at diagnosis of diseases and conditions mentioned before. Another advantage of this technique is that there are different types of this machine available: the closed MRI machine, standing MRI machine, and open MRI machines. Closed MRI machines are the traditional ones. However, the open MRI machine has also other advantages. For example, it's suitable for people with claustrophobia or anxiety, and also they are much better for people who are unable to lie flat for long periods of time or need to be observed during such scans. And the last MRI advantage is that the technology is being constantly developed to give even more clear and more accurate images in a shorter period of time. Now we're going to focus on the limitations of MRI technique. So although MRI analysis doesn't involve ionizing radiation, as mentioned before, it does use a strong magnetic field. This may be a health hazard for patients that have implants that contain magnets or metal, as the magnetic field in MRI machine might move the implant and cause injury to the person. This is a very big limitation to the technique, and appropriate actions need to be taken during such scans, such as surgically removing the metal before the scan or using splint or bandaging kits. Another limitation to this technique is loud noise, with intensity up to 120 decibels, which means that patients may need ear protection. Although there are now more open MRI machines, not every place has them, and they're not suitable for all examination, which brings up another limitation to this technique, which is a very tight tunnel where scan is taking place. Some people, for example with claustrophobia, might find it very difficult to be inside a narrow tunnel for a scan. Furthermore, MRI machines are also not practical for overweight people.